Okay, good morning again, guys. Please turn on all your cameras. Okay, guys. So the topic that we have for today is about reactivity series. But before we move on to the deep part of reactivity series, let's start first the metals. The reaction of metals into oxygen, reaction of metals to acid, and reaction of metals to water. So there are three reactions of metals into three substances. So we can use our book for that topic as well. You can open your book on page 182. So, but then I will use the slide to discuss the reactivity series. Okay. So can you please get first your book so that if there is a follow-up question that you see there in your book, because we'll be using the slide, so you can ask question. Okay? So but then after this, after the discussion, we'll be having a short activity or a short quiz related to the topic, of course. So let's start. Okay, so the first topic is about metals and oxygen. So the reaction of metals to oxygen. So how does metals react to oxygen? What will happen if we mix up metals into oxygen? Okay, some metals react quickly and some only react very slowly. So meaning of quickly, so there is a quick reaction that will happen once the metal exposed to oxygen. So as you can see there in the picture, so it happens that it produces like a spark, a white spark happen when the metals reacted to oxygen. So as the time that we recall, or when we recall the metals that we have in the periodic table, so can you please name some metals that we have in our periodic table? Those metals that we already discussed. Anyone? Anyone can impart the lesson about the metals? Name at least one metal. Joseph?
Yeah, miss.
So can you please name a metal?
Iron.
Okay, iron. So when the iron reacted to oxygen, so what will be the product? So it says in here, one of the example given in here is magnesium, right? But we'll be using the iron. So iron, for example, burns in oxygen, it will produce a bright flame. So like what you see in the picture. So when a metal reacts with oxygen, the product will be a metal oxide. So of course, the name of the metal that you just mentioned. So let's say an iron plus oxygen, the result will be, or the product will be, iron oxide. So as you can see, there is a name metal there. So the metal and the oxygen, they are what? These two things. So we call it as a reactant. Okay? So both of those substances or elements are reactant. And this last is said to be the product. Okay. So once the metal and the oxygen react to each other, we call that process, or we call this reaction as oxidation. Get it? Do you get it? Please respond.
Yeah.
Okay, another example of metal. Can you please name an example? Another example. So we mentioned already iron. We also mentioned here in the slide, which is magnesium. What are the other metals that we have? Any metals? Can you please name other metals? Terence? Again?
Yes, yes.
Aluminium.
Okay, aluminium.
Miss, did you call me, miss?
Yes, I mentioned your name a while ago to please share a metal that react to or which is reacted to oxygen.
Copper.
Okay, copper. A while ago, someone says an aluminum. So let's just do first the copper. So copper plus oxygen is equals to copper.
Copper oxide.
Okay, so that's how you will do the equation, yeah. So you will think of a metal that will possibly react to oxygen, then the product will be the name of the metal plus the oxygen. So therefore, copper plus oxygen, the product is copper
Copper oxide.
oxide. So again, the reaction that we said about that is oxidation. Next. Okay, so let us see this example. So we have three types of metals in here. So they are magnesium, copper, and iron wool. So let us see what will be the reaction or what will be the things that will happen after they are exposing to oxygen. So let us play. So the first one, a piece of magnesium will be heated in a Bunsen flame or in a Bunsen burner. So let's see what will happen. Okay, so you see what happened, right? So later I will ask you about that. So this jar, at first it is covered with a lid, right? So and then the lid removed. Inside it, of course, there will be some amount of oxygen as we covered it, right? So the magnesium oxide is being placed inside the empty jar. Empty jar, but inside it there is an oxygen. So how reactive is magnesium with oxygen? Okay, later you will answer that. Next. The second one is the copper. Same procedure. The copper will be burned in the using the Bunsen flame, will be placed inside the jar of oxygen and see what's the result. Okay, so you can see already the result of the magnesium and the copper, right? The last one is the iron wool. So same procedure. Look at the effect. And then will be placed inside the. Okay, so after placing inside the jar, is there something happen? So before I give you the summary, let me ask first at least three of you to compare the result of magnesium, copper, and the iron wool. Okay, may I heard some words from Jocelyn? Tell something about the result of magnesium when it is placed or when it is exposed to the Bunsen flame or to the fire. What happened after placing it inside the jar of oxygen?
It will become magnesium oxide.
It becomes magnesium oxide, but what is the result? How you will describe it? Do you want me to go back again and see the effect? Okay, let us watch again. So see, the magnesium is producing some like a flame, right? After the flame, it turns into an ash. Next. So that is the description. So after exposing it to the flame, when it placed into the jar of oxygen, the magnesium produce a flame or a fire or a spark, white spark, and then after that it produced an ash. It ended into ash. So how about copper? Anyone? Rowan. Rowan, are you there?
Yes, miss.
Okay, Rowan. Can you tell us something about copper? What can you
Uh,
say about the reaction of the copper?
when the copper is in the water, the reaction is low compared.
There's no water. There's no water. It's an oxygen. It's not a water. It's an oxygen inside it. So what have you seen? What color have you seen inside the jar? After the copper is placed inside the jar of oxygen.
There is red, yellow, and orange.
Okay, it produced like an orange color. And then, what about the copper? Does the copper turns into an ash?
No,
No, right? It's just a burned copper, right? The
yeah,
copper is still a copper, but it turns into the black one. So it is already burned. Next. How about Farrell? Are you there?
Yeah.
Okay, so tell something about the result of iron wool.
It will be metal oxide.
Okay, it turns into a metal oxide or iron oxide. And then after that, what happened? Does it turn into ash? So what happened to the reaction before you place it inside the jar of oxygen? While the iron wool is still with the Benson flame, it produced like a spark, right? Like a red-orange spark. And then when we place it inside the bottle or a bottle of an oxygen, so it produced what? Does it produce something like magnesium? It feels like nothing, right?
Yeah.
Okay, let us see the reaction. So these are the summary of the reaction of the three metals. So we have here, right, the magnesium, copper, and iron. So magnesium, the reaction of it to the oxygen is the ribbon burn with a dazzling white flame giving gray-white smoke and ash. So it turns into ash after that. While for the copper, it turns into red and orange, then slowly got a permanent coating of black because it is already burned. While for the iron, it glows red during the exposure to the Benson flame. Then after that, a brown black solid produced when it is exposed to or when the iron wool is placed inside the jar of oxygen. So question about that. Question about how the metals reacted to oxygen. Any question? Okay, if there is no question, let me ask you one question. What reaction, what is the name of the reaction of metal that is being reacted to the oxygen? If the metal is reacted to oxygen, what reaction is that? Vivian,
Yes.
what is the name of the reaction when metal is reacted to oxygen? We call it as oxy. Any idea? Can you please continue the word oxy? We call it as oxidation. Please remember that, yeah? the name of the reaction that will happen when the metals reacted to oxygen, we call it as oxidation. So again, can you please say it? Oxidation.
Oxidation.
Okay, let's proceed. Okay, can you please arrange this series of reaction from most reactive to the least reactive with oxygen based on the given examples a while ago, how they react to oxygen. So which one is the most reactive and which one is the least reactive? This arrangement is not arranged properly. So can you please arrange it properly? Can you please arrange it properly? So the first one in the choices is iron, followed by magnesium, and last is the copper. So which one is the most reactive based on what you have based on what you watched a while ago?
Magnesium.
Okay, very good. The first is magnesium, followed by
Copper.
Iron.
copper, or followed by iron.
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 How about you, Chanel? What is your idea? Which one is the second one? Is it iron or copper?
Copper.
Okay, you said copper. How do you say it's copper?
It had a flame.
Does the copper produce flame
Miss, I thought it's iron.
or the iron? The iron produce flame while it is exposing to Benson flame or while exposing it to fire. Okay, let us see. Let us solve. Okay, the first one is magnesium followed by the iron. Then the last is the copper. So as you can see to the second one, when the copper is exposing to the flame, so the copper turns into black, right? And then when we place it, or when the copper is being placed inside the jar of oxygen, so it looks like there is a small color produced, or a light color that is being produced like an orange, but there is no much reaction after that. But then when we put the iron into the Benson flame, it produces a spark or a red-orange spark. Then after that, when we place it inside the jar of oxygen, so it's just producing a black or brown object or iron. Okay, so that is the arrangement, yeah. The most reactive is magnesium, the second is iron, and the last is oxygen. The last is copper, based on the given example. Okay, next. Okay, so this one, what is the balance symbol equation for each reaction? But before you answer that, I want to ask you first whether you already learned about balancing, how to balance a chemical. Do you know how to do the balancing already?
No, miss.
I think for Terence, Marcel, Shan, they already
Yes.
have an idea how to do the balancing. Am I right?
What, miss?
The
Balance.
balancing of the chemical. Or you forget it already. How about last year? Did you discuss already balancing? Because we need it here.
No.
Even I explain it that this one, let's say magnesium plus oxygen and magnesium oxides are already balanced. If you did not know yet how to do the balancing, then I cannot proceed on it. So I will stop in here, yeah? So we will continue the topic later about the reaction of metal to water and reaction of metal to acid after the discussion of balancing. So I will cut this one first. We will proceed first to the balancing. Okay, so there are 5 easy steps in doing the balancing. So the first one, so let us please take a note of it so that later if I will give you an activity, you can easily answer it. So sometimes in writing a chemical or in writing a formula or an equation, so it will be written as this. So let's say 2, that is 2, let's say 2, yeah. It's just an example because I want you to be familiar first what are these. So we have in here SO4. S is sulfur, O is oxygen. So there are 2 numbers before the elements and after the elements. So this 4 is written in small number. Okay? Remember this, yeah? We call this number as a subscript. Okay? And then we call the other number, this number 2, as a coefficient. Please take a note. Make a note of this. Okay. So coefficient can be changed, while the subscript, sorry, I forget, cannot be changed. Okay, remember that, yeah? In writing a subscript, the subscript of the element, it is as is. You cannot change it. If it is 2, if it is 1, if it is 2, if it is 3, 4, 5, 6, and so on. So that is remain that number. So you will not touch anything about that number. But then if it is coefficient, you can erase the coefficient and change it into another. So you can make it as 3, 4, 5, 6, and 7, and so on. So, but then if you will just make the coefficient as 1 only, no need to write anything. Remain blank. So, just remove the number. So, automatically, meaning if there is no number before the element, meaning that is 1, counted as 1. And then, if for the subscript, let's say there is no number that you see in there, just SO, just sulfur and oxygen. So meaning, sulfur is just only 1 atom and oxygen is also 1 atom. Okay? So this number 1 will not also be written. That is automatically 1 if there is no number. Do you get it? Get it? Do you understand, guys? Okay, so again, yeah, if there is no number at the bottom part of an element, so meaning that is counted as 1. If there is no number before the element, so that is also 1. Okay? So let me now give you an example. So let's say I have in here S, sorry, it must be S8. So let's say S, sulfur with an atoms of 8 plus oxygen with an atoms of 2. So we call this S8 plus O2 as a reactant. They are the one that will be reacted. So this sulfur will be reacted to oxygen. So what will be the product? Sulfur oxide, right? So how to write the sulfur? Or how to write the product of these two elements? So we have SO2. Okay? So let us see whether they are balanced or not. So this is now the first step on how to make balancing. So let us divide the reactants into the product. Separate the reactants to the product. So what are the elements that we have? So we have sulfur and oxygen for the reactant. So of course, for the product, you also have sulfur and oxygen. So do we have coefficient for this reactant? Is there any coefficient that we have? For letter S, for the sulfur, do we have coefficient? No, right? There is no coefficient. What we have is just a subscript. Both of the reactant and the product, we don't have any coefficient. We only have subscript. How many number of atoms do we have for sulfur? We have 8. How many numbers of atoms do we have for oxygen? We have 2. So for the product, how many number of sulfur do we have? There is nothing at the bottom of the sulfur, so therefore that is 1. But for the oxygen, we have 2. So as you can see, the number of atoms for the reactants and the number of atoms for the product, they are not the same. So meaning, they are not balanced. So what we're gonna do is to balance them. So how to balance it? What are the operations that we need to use in dealing with the balancing? So the only operation that you need for that is either plus or multiplication. Okay? So what we're gonna do first? Which one we need to follow? We cannot subtract. So as I've said, just addition and multiplication. So the multiplication will be used if there is a coefficient. So the coefficient will multiply to the number of atoms. Do you understand? But
Miss, can
then
you
for,
give another example, Miss? I don't really understand.
we are not yet done with this. We are not yet done. This one is not yet balanced. We are still doing the balancing, Joel. So again, yeah, let me repeat. So the only operation that you will use for this balancing is addition and multiplication. So multiplication will be applied if you are going to multiply the coefficient to the number of atoms. Okay? This, let's say letter C is coefficient. Coefficient multiplied by number of atoms. So the number of atoms will be found at the subscript. This is the subscript, right? So, but then for this example, there is no coefficient. But we can put coefficient for this example. Okay, so we need to follow the reactant. So how can we make this, how can we make the sulfur becomes 8? Because in the product part, the sulfur is just only 1. Am I right? The sulfur is just only 1. So how can we make it balance? So what number are we going to put as the coefficient to make it 8?
7.
If we're going to put 7, so 7 multiplied by 1 is still 7. 7 times 1 is 7, right? So therefore, cannot. So this 7 is not the correct answer. So what number are you going to put? So let us try 8. Because we need 8, right? So as I've said, coefficient can be multiplied to subscript. Sulfur in the product side, we only have 1. So 1 times 8, the answer is 8, right? So for our sulfur in the reactant and our sulfur in the product, already balanced. But we are thinking now how to make this oxygen balance. Is this balanced already? Cannot. Because if we put 8 in this part, we should multiply this because they are together, right? They are not separated. So they are in one product. So how can we take it? So 2 times 8 is equals to 16. So still, our sulfur is balanced, but our oxygen is not yet balanced. So what can you do? What we can do to make it balanced? We can add 8 to oxygen as a coefficient. So 8 times 2 or 2 times 8 is 16. So now they are balanced. Question. So that is the first example. Did you copy it? Any question about this part? Because I will give another example.
No.
Okay, so let me repeat.
I need to copy.
Let me repeat about this. The only operation that we can do for that is addition and multiplication. Where can we use the addition? If one of the element will be written twice there in the, it's either in the reactant or in the product. So you can add it. So later I'll give an example about that. So let us make another example. So let's say our example is oxygen plus, hydrogen plus oxygen is equals to water. Okay, how can we make it balance? So again, we separate the reactants. So these are the reactants. Hydrogen and oxygen are the reactants. And then H2O is the product. So how can we make it? So hydrogen, again, write first the element. So it will be easy for you to see it. But if you already mastered it, no need to do like this. You can do it without writing anymore the separation of elements for both reactants and product. Okay, so how many hydrogen do we have? We have 2. And how many oxygen do we have? We have also 2. Okay, so for the product part, we have 2 and then we have 1. So our hydrogen is already balanced, but our oxygen is not yet balanced. So how can we balance it? Anyone? So we need to add more for the product part again. Any answer?
Times 2.
Again?
Times 2.
Where are we gonna put the 2?
Beside the 1.
Beside water. At the product part. In this part?
Yes.
Let us use other color. Okay. Even is the one answering, right? Okay. So we'll try. So 2 times 2 will become 4. And then 2 times 1 will become 2. So the other side will not be balanced. So what you're gonna do to make it balance? Because no matter what, you need to add the coefficient for the product to make it balance. So what you're gonna do
Times
to
2.
make them times 2 to where?
H.
In this
Put two to
reactant,
H.
yeah. Okay, so we'll try 2 times 2 is equals to 4, and then 2 times 2, oh no, there's nothing in here already. Very good. Okay, are they balanced?
Yes.
Okay, very good. So that's the second part to make it balanced. So another example. So because the example is just easy, yeah? So we go on to a bit complicated. Not actually complicated, but to have more practice. We will add more element. So let's say, for example, for this third example, so we are at the third example, we will count, so this one, let us count polyatomic as one item. So when we say polyatomic item, they are the SO4, NO3. So those with the compound already. So no need to separate them one by one. So let's say, for example, I have here so let's say we have Ca. What is Ca? CaSO4 plus so A O3. There is a close and open parenthesis, yeah. Same thing with the mathematics. If there is a parenthesis, you have to multiply, right? Then plus S4. Yeah, this one is 4. Okay, so how can we write it? So what did I say a while ago? Count polyatomic as one item. So we have in here calcium. Okay, followed by, so what are the elements that we have in there? Can anyone dictate what to do for the second step after writing the SA? I mean the CA? Anyone? What's next?
Right equals, miss.
To where? No, not the equals. What's the next first? Let us write first the element. So as I've said, right, the polyatomic as one item. We count polyatomic as one item. What are the polyatomic? So the polyatomic are this. SO4. So SO4 is sulfate. So let's say we make it as one already rather than per element because they are one only. SO4 meaning that is sulfate. Okay, remember that, yeah? If it is SO4, they are counted as one. They are a compound. So because a combination of two elements, so we just write it as one item aja. No need to separate the sulfur and oxygen. So what is the other what is the other element that we need to write?
Na, miss.
Okay, so we have Na. And then another polyatomic. What is the other polyatomic is NO. NO3 is nitrate. Remember this. When you see SO4, that is sulfate. When you see NO3, that is nitrate. Okay? So now let us write the number of atoms of these elements and compound. So for the calcium, how many? How many number of atoms? For the calcium, how many number of atoms?
1.
Okay, we have 1. For the SO4, only 1 as well. Because only 1, right? You did not see any SO4 again in this reactant, right? So the other SO4 will be found at the product. So they are different. You cannot count them as one from the reactant and one from the product. So it is different. So for the sodium, we have also 1. And for the nitrate, we also have 1. So on the other side, product side. So we have 1 calcium. We have followed first the SO4. Although the NO3 is the second one. How many SO4 do we have? Also 1. How many sodium do we have? How many sodium do we have for the product part? How many sodium? Sodium. Na. At the product side.
1.
This is the product side.
6.
2.
Okay, we have 2. And then for the nitrate, how many? So as I told you a while ago, same thing with mathematics. You must multiply if you see a open and close parenthesis. So you will see there, NO3 niya is inside the close and open parenthesis. So we have 3 in here, and then we have 2 outside the parenthesis. So 3 times 2 is equals to, 1. Only 1 NO3 times 2 is?
No.
2.
Okay. 2. So are they balanced? Not right? They are not balanced. So Ca for the calcium, it is balanced already. For the sulfate, we have balance already. It is balanced already. But for the sodium and the nitrate, they are not balanced. So what you're gonna do? So which part do we need to touch to make something different? At the reactant or at the product? In this side or in this side? Left or right?
Left side.
Okay, at the left side. Because all at the left side are 1. So we cannot subtract, right? What we need is just addition or multiplication. So for this sodium, what you're gonna do? Because the sodium at the product side, we have 2. While for the reactant side, we only have 1. So this is the part. So we can add 2, right? So 2 times 1 is already 2. So but we have problem. So how many sodium, how many nitrate do we have in here? 1 as well, right? 2 times 1 is also 2. So therefore, they are already balanced. Do you understand?
Yes.
You get it now? Okay. Do you need more examples? Do you want more examples or not? Okay, last one example, yeah? Still have how many minutes? Okay. So next example. So this is the number 4 example. So let's say we have carbon, hydrogen, plus oxygen, carbon dioxide, plus water. Okay. So this time we can apply the addition. Okay. So what are the elements again? So let us separate it. And then, so we have chalk. How many carbon do we have? 1. Hydrogen is 4. Oxygen is 2. So on the other side, we have same thing. So how many carbon do we have at the product side? We have 1. How many hydrogen do we have? We have 2. How many oxygen do you have at the product side?
2.
1,
How many?
1.
Only 1 for the product side. So
Oh,
for
three,
the
three, three.
carbon, okay, so we have 2 plus 1. So you have 3, right? So that is the oxygen, the number of atoms in the product side, we have 3 oxygen. So not yet balanced, right? The only balance is just the carbon. While for hydrogen and oxygen, they are not balanced. So what can we do? Any idea on how to solve it? How to balance it? Which part? Do you need to change something? So for the carbon dioxide, nothing to do, right? Because our carbon is already balanced. So what can we do? We better put coefficient at water part. So this one. So let's say I will put 2. So of course, hydrogen niya will turn into 2, right? So I have 2 balance already. Carbon and hydrogen both balance. So 4, 4, 1, 1. So but then for this part, this one will turns into 2 times 1, right? 2 times 1. So the oxygen niya will be 2 at first. How many oxygen do we have? 3, right? So we remove this one first. We erase this again because there is a changes in here. So the changes niya, the 2 at the water part will turn the oxygen into 2, right? So therefore, it will become 2 times 2. So therefore, our oxygen is 4. So, but then for the other side, our oxygen is 2. So what we're gonna do? To put 2 there, so 2 times 2 will turn into 4. Get it?
Yes.
Do you understand? Okay, so I think it is all clear now. So that's how you balance the equation, okay? So maybe later we can, I will give you at least 5 examples that you will answer by yourself. So, but then for the meantime, it's already 8:53. So, no much time for the discussion of the other reaction of
The break
metal.
time,
So,
Miss?
yeah, later we will continue the discussion. But for the meantime, let me thank you first for listening. I hope you understand already the reaction of metals with oxygen and then how to do the balancing. Is there any question about the two topics?
No.
Really? Okay, so but then if there is a question that will come up or that will enter into your mind, don't hesitate to ask question. Okay, so I will give you now time to break. So thank you for this session. See you again later.